Are we back? Are we back? Okay, it looks like we're back. Okay, I do apologise. Yeah, my laptop's playing up a bit. It's freezing. Uh, but yeah, it sucks. The stream's disconnected. It's gonna be a two-parter then. Uh, but yeah, we're gonna pick this up where we left off. So the last time we were looking at inverse functions. Uh, uh, no, it won't let me write on here. Okay, there we are, back again. Oh, God. Uh, Hang on, let me just check. Is everything working on the stream? I forgot. What's going on now? Okay, see, hopefully it is working fine. Okay, let's just jump right back into this. I do apologise. The laptop plate freezing, so I have to reset it. Okay, yeah, so last time we left off on composite functions, I don't know how much was heard. But yes, so the idea is, yeah, so we ended up with solving this. So we understand that this means composition. We are substituting f of x, so 3x plus 4 into g. And that's what we're doing. So we got root x, which is, instead of x is 3x plus 4, so root 3x plus 4 plus 2 over 5, and we are told this is equal to 3. Okay, so solving for x, get rid of the fraction, so times by 5, 3x plus 4 plus 2 is 5 times 3, which is 15. And then get the x on its own, so move the 2, subtract 2 to both sides, 13. And so then we want to get rid of the square root, so square both sides. 3x plus 4 is 13 squared, which is 169. You should note 13 squared is 13 times 13, which is if you are stuck on that again, it might some of the non-calculator is obviously meant to assess your arithmetic, so some of it might be a bit like you might second guess. If you want to be sure, just do a quick long multiplication, okay, and you'll get 169, okay. But yeah, we get to that, so now we just solve for x. So that means 3x, then move the 4 across, 165, subtract 4 to both sides. 169 minus 4, 165. So that means then x is 165 over 3, which is 55, okay? You should spot maybe 150 is 50 times 350. Then we need to get another 15, and that's how you get 55. Okay, so that is our solution here. Again, I do apologise about that, splitting the question up. But yeah, we did part A last time, but now this is a continuation of the last stream. So now we're solving part B. So now we're going to move on to question 19. Okay. Again, they love asking third questions because again, like I said, you can just bung it into a calculator in theory. So they like asking this in non-calculator. So expect third, you need to learn your third rules. And then really the main one you need to learn is root AB through 8 times root B. That's your third law you need to remember. And it'll come into help here. So we're told root 5, root 8 plus root 18 can be written in this form, and then also find it out. So we need to expand this, right? Okay. Now, notice when you're adding two thirds. So, firstly, notice we're going to have to deal with what's in the bracket, right? We have root 8 plus root 18. And we're adding two thirds. Now, when you add two thirds, um, you have to make sure they both have the same root under. That's the only way you can add. So what we're going to need to do is simplify root 8 and root 18 and see what we get. And we're going to use this law. This third law is going to be massive help. That's how we're going to do it. So root 8, well, root 8 is uh, root 4, well, it's 4 times 2, right? So it's root 4 times 2. And we can split this up. So it's going to be root 4 times root 2. And actually root 4 is 2. And so it's 2 times root 2. Likewise, root 18 is going to be well, we could say it's 9 times 2. Just think of a product, right? Split it up. And so actually it goes to root 9 times root 2. Split it up. Which is 3 root 2. Because root 9 is 3. 3 squared is 9. Cool. So now, like I said, the only time you can add two thirds is when they have uh the same square root, right? It's root 2. Okay, it has to be the same number. You can't add root 2 plus root 3, for instance. You can't do that. You can't do anything with that. So the objective when you're adding is to find a way to convert it and simplify it to the same number, which we have here. So this is I'm saying 2 root 2 plus 3 root 2, which is 5 root 2. And that is the main idea with thirds. When you add, you need to simplify it to the same number, like I've done here. We're using the third law, okay? And so therefore, the product then, so our answer is going to be root 5 times this, right? This sum. So it's 5 root 2. And actually, like with this, if we can bring two thirds multiplied together, we can bring it as 1. So this is going to be 5 root 5 times 2 because they're both inside roots. We could bring them together. And this is then 5 root 5 times 2, which is 10. And actually, this is our answer here. So actually, A has to be 5. Notice it mirrors this answer here at 5. That is how you approach these thirds, okay, these third questions. You want to make sure you find a way to simplify to get the same root, okay? And when you times, you can split the third up. That's all you need to know, okay? I think people overcomplicate it a little bit. And all the third is as well, it's just quickly, is a number which isn't a square root. So this root, so it doesn't give a whole number. So um, root 2 is and root 3 are thirds because they're not 2 and 3 are not square numbers. So this will not give a whole number. But root 4 is not because root 4 is 2. That is a whole number. That is not like a decimal. But then root 5 is a third because that 5 is not a square number. So really, the number just can't be a square number. So that means that this doesn't give a whole number. So third, anything that isn't like root 1, root 4, root 9, root 16, these are not thirds. But anything else is a third. So root 2, root 3, root 5, root 6, root 8, but root 10. But hopefully so that's just a rundown of thirds, okay? I'm not going to go too much, but you should remember that's the process, and this will be a non-calculator thing. I strongly predict this will come up, okay? So it's best you learn it. But yeah, so that's the answer to that. Lovely jubbly. Okay, 1 question 20 now, out of 25. So again, part A, again, they love asking these sort of bracket questions, expanding brackets. They love asking questions like this. So factorize, expand, and simplify. Okay. So factorize a squared. minus b squared, you need to recognise this is difference of two squares. Okay, and you can double check your answer. If you expand and simplify, you get back this. Okay, so that's factorising. You need to recognise that for 1 mark. You just need to know it. And then it says part B, hence or otherwise simplify this. Hence, key exam tip, you need to use your other part of the question. You need to use this somehow. But actually, recognise it looks like this. Okay, it looks like a squared minus b squared. Let's make this direct. Okay, let's say a is x squared plus 4 and b is x squared minus 2. Well, isn't this the exact same as saying a squared minus b squared? Isn't that exactly the same? Look, something squared minus something else squared. If you make it, you can use substitution. Use this to make it clear. That's exactly what's going on. But did we not then say that this is equal to a plus b, a minus b? So then we can resubstitute the back in. So let's see what happens. So a is x squared plus 4 plus b, which is plus x squared minus 2. And then a again, x squared plus 4 minus b, so minus x squared minus minus 2 is plus 2. And now let's simplify and see what happens. So x squared plus x squared is 2x squared plus 4 minus 2 is plus 2. And then x squared minus x squared is 0. And then 4 plus 2 is 6. So actually, this is then saying 6 times everything in here. So 2x squared plus 2. And then you can times it out to simplify. Let's times it out. 6 times 2x squared is 12x squared. And 6 times 2 is 12. And that is your final answer. Notice how this is simplified a lot more than here because we're using part A. So that's the exam tip there. They love asking questions like this as well. But hopefully that's clear. If you vaguely recognise like something like this, and you recognise it from somewhere else, just use a substitution like this to make it clear. Don't be afraid to use algebra and stuff and substitute stuff in. Then you make it abundantly clear what you're doing. Okay, that's the sort of method to go through here. Okay, I need to plug my charger in. But yeah, this next question is recurring decimals. This doesn't come up too much, if I'm honest, but it they love asking this for non-calculator because obviously you can't have a calculator to give you the answer. So here it's saying work out this decimal, recurring decimal times this. So they love with recurring decimals, they love making you do like arithmetic. So they give you two different recurring decimals and expect you to do something with them. So again, with like every other what I've said so far, split this up. So do the first recurring decimal and then the second one. So you need to know to convert this into fractions, okay? So 0.54. So again, with the process, as you should know how to convert a recurring decimal to a fraction. So the first step is that x is 0.54. So then there's 2, so we're going to need to times by 100 to move the point by 2 forward. And actually, you need to be careful here because we want to align it together, right? And that's 54 recurring again. So actually, x is, if we write this out then, recurring just means it goes on in this pattern forever. So x would be 0.545454, and then 100x is going to be 54 So 54.545454. Now, actually, what you want to do is you want to subtract 100x from x, so that means you're left with 99x. And actually, if you substitute the fraction, the decimal part, they will cancel each other out because they're exactly the same. So then you're left with 54 minus 0. So 54. Okay, 54 minus 0. 54 minus 54. They're the same. They will cancel. So you're just left with 54. Yeah, 54. And then x then, which is our original decimal, is 54 over 99. Okay. And can we simplify? Yes, we can. I believe. Yes, because let's check if they simplify. Um, well, 3 doesn't go into 54. 4 doesn't go into 99. 5 doesn't. 6 doesn't. 7, 11. If you play around a little bit, 11 goes into both of them, right? So 11 goes into 54. 1, 2, 5 times, right? And it goes into 99. Uh, 10, 9 times. No. 5, 6, 7, 8, 9. What? I can't. God. Um. Uh. Yeah. 54, 5, 63, 72, 81, 90. Let's see. No, it doesn't. No, it doesn't. Hang on. 11. No, of course it doesn't go to 11. I remember. I don't know why. I remember 11 from something else, so that's why I got 11 in my mind. I don't know why. Um. What about 9? No, yeah, 9 goes into it. Yeah, of course. 9 goes into 54, doesn't it? Uh, yeah, it goes into it 6 times, doesn't it? Oh yeah, yeah, that's what I was doing. I was remembering the 9 times table, but somehow, for some reason, I said 11. That's why I was getting so confused. I don't know why I mixed 9 with 11. I don't know. Yeah, 9 times table, not 11. I don't know what happened there. 6. Yeah, so 9 times 6 is 54. And then 9 is obviously 11. That's where I got the 11 from. Yes, 99 divided by 9 is 11. Oh man. Double check that because I don't know why. There's a lot of some issue there. I don't know why. 980, 36, 4, 45, 5, 54, 6. Yeah, that should be right. Okay, bloody hell. Okay, so that's X. That's the first decimal. Now, let's again convert the second one into a fraction. So now let y, another one, be 0 0.5. So 10y, so we only need one decimal, so we only need to times by 1. Move it by 1, so times by 10, not 100. That's going to be 5.5 recurring. So again, then what we're going to do is what actually should have been 10y, shouldn't it? Put 10y at the front. So 5.55, and y would be 0.55. Okay, that should make it a lot clearer. Minus 10y minus y. So the bigger number minus the smaller. It's the other way around, but it doesn't matter too much as long as you get the x here. Okay. So 10y minus y, that's going to be 9y. And the idea is, again, the decimal part cancels. That's the main idea with these fractions, the decimals. The recurring decimals, when you do this, you should make it so the decimal parts cancel. So this will cancel, so you're left with 5 minus 0, which is 5. So therefore y is 5 over 9, which does not simplify. Okay, so that's all good. So we've got both of these as fractions. Well, we know the types of fractions, don't we? So actually, 0.54 recurring times by 0.5 recurring, that is 6 over 11, because we know this is x, which is 6 over 11, times 0.5 recurring, which is y, which is 5 over 9. And so 6 times 5 is 30. And 11 times 9 is 99. And yeah, so that's fine, actually. We've worked it out. We don't need to simplify this anymore. Does it simplify? Uh, yes, because 3 goes into both of them, don't they? So I guess you could say that's 10. If you want, you don't have to because it doesn't say to simplify, but that is same as like 10 over 33 divided by 3 both sides. I don't think that simplifies anymore, does it? 4, 6, nah. 10, 5, 5 and 2 goes into it, really. That's about it. Doesn't go into that. Anyway, that's the answer. So hopefully it makes sense. So again, recurring decimals, to make the numbers nice enough, I guess, so you don't need a calculator. They can ask you this, and it stops you putting it just into your calculator. So again, they do like for 4 marks, they do like asking this, and a common recurring decimals question. They love asking you 2 recurring decimals and ask you to multiply or add them or something like that. So what you do is convert both of them into fractions, so individually, and then you times the fractions and add them. Okay. So that's the step there if it comes up tomorrow or whenever. Okay, hopefully that helps. So question 22 now out of 25, you're getting there. Circle theorems. It's kind of 50-50 what will come up in paper one. Well, I guess you'd say 33% because there's 3 papers. But I've seen it come up a lot of times in paper one for some reason. But they can ask it on any paper, but it's good to go over it. So circle theorems, you should know uh, you should have an idea in the back of your mind what they are, so what to use. So, angle at center is double angle circumference. So I'm just making a rough note. Double circumference, angle. I'm just making it a rough note. I'm not making it like proper. That's one of them. You should know radius and tangent perpendicular. Okay. You should know alternate segment theorem. So just alternate segment for now, just listing it. You should know opposite angles in cyclic quadrilateral add up to 180. And there was another one. Oh yeah, angle in a semicircle is 90 degrees. So those are the main ones. Uh, I forgot to say. There we are. Okay. Oh God. It's 90 degrees. Okay, there's like I think there's one more. So if there's 2 different tangents that meet the circle, for God's sake. There is another one. Those are the there's one more, but so it's like if you have 2 different tangents that go at the same point, and they're both tangent to the circle from the same point, they're equal in length. Okay. But clearly there's only one tangent here, so we're not going to use that. it will often actually be pretty clear which ones you need to use given what they tell you. So we have a tangent here and a radius, so we're obviously going to have to use the tangent and radius and tangent perpendicular. We are also given an angle at the origin, and there's also another angle at the circumference, so we're going to have to invoke this as well. Alternate segment, maybe as well. It looks like an alternate segment. But I'd like to leave that till last because I think that's the most complicated one, in my opinion. The other one's they're fairly obvious when you use them. Okay, so it says to find the angle ADC. So that's going to be this angle here. Okay, I'll call that angle X. Cool. Okay, so with circle theorems, think about what you know, what you're given, and then work your way. So what do you know, first of all, and what can we do? So we're given an angle at the origin, um, and we also have an angle at the circumference. So how that works is, if we have an angle at the origin, and we have two different radius here, like we have here, one radius here, OB, and with another radius OD here. If they both then go up to two different radii, go on to meet at the same point on the circumference here at A, this angle and this angle will the angle at the circumference can be half the angle at the center. So because of that, this has to be 32. So angle B A and this triangle here, so BAX here, so this intersection X here. Or you could call it BAD. I don't know, BAD for now. We'll leave that there. Angle BAD, BA to D. That has to be 32 degrees because angle at circumference is half the angle at the center. Okay. So make sure you learn the phrasing here. So it says write down any circle theorems you use. So there we are. So that's 32. But what else can we do with that? Well, actually, this is a triangle here, which is why I said, let's label this vertex X. No, actually, oh, that's confusing, wasn't it? Let's call this F, because there's no F there. Okay, F. So, yeah, so a triangle BAF. So actually, we know this angle here as well. Well, this angle here, uh, and where are we going to go with this, do you reckon? Well, we can then look at that angle, and then we know that angle, and then actually, if this is a perpendicular, we can work out X. But yeah, that's just a rough sketch where we're going towards. Okay. But anyway, so angle F. So this angle here, which is BAF, and the AFB, sorry. The ordering matters here. So alphabetical, but the angle has to be in the middle letter. Okay, so angle F. Well, that's going to be 180 minus minus 51 minus 32, the two angles in the triangle. Well, that's going to be, well, what's 51 plus 32? Rough joins. That's going to be 83. So 180 minus 83. Um, well, that's going to be 97. 97 and 83. Yeah, 180, right? 97 and 83. Cool. Yeah, and that is because you don't actually. Okay, it doesn't tell you to write. It only tells you to write down any circle theorems you use. You do not need to write the fact that angles in a triangle add up to 180. That's not a circle theorem. You could, if you wanted to, as angles in a triangle add to 180. You could write that if you wanted to, but you don't have to. But yeah, I'm going to need to make more room here, actually. There's not a lot of room here. So yeah, so hopefully you realise well that's the case. So yeah, but then I said, well, we know this angle as well, which could be useful. Uh, DFO. So angle DFO. Well, they're vertically opposite, aren't they? They look like this. So this angle is 30. No, it's 97. So this angle's also gonna have to be, for God's sake, also has to be 97. They're vertically opposite. So therefore, it's 97. So that's DFO, okay? And actually, we know this angle as well. And uh, therefore angle, this angle is so FDO. Well, that's going to be 180 minus 64 minus 97. And that's going to be what? Well, again, roughly, 97 and 64. That is 171, is it? Yeah, 101 at 60. No, 61. Right? Hang on, I need to check here. 101 at 60. 61. Is this right? Minus 51. Half of that is 32. 29. It should. Okay, I think that's right so far. Again, double check your mental out working out. Wow, that's 180 minus 161. Well, that's going to be 19. Cool. Okay, so that was 32. So let's label it as we go along. 32. This was 97. This is also 97. So now we know this angle, but actually we know that this whole angle here. I'm gonna make it clear. This angle here has to be 90 because a tangent and a radius meet at 90. As does this angle here, the x and 19. So therefore, x plus 19 has to be 90. And this is because tangent and radius are perpendicular. And I'm going to have to squeeze this in here, so apologies. So that's a circle theorem that you do have to reference here because it says write down. Well, x plus 19 is 90. Well, x is going to be what? 71. 71 and 90 gets you 90. So that's your answer here. That's the angle ADC. Okay, this angle here. That is 71. Okay, sorry, apologies, a bit unclear. I had to squeeze it in. I didn't get a lot of working room here. Yeah, so that's the gist of it. Okay, so with these circle theorems, list the one you should know them all. Kind of have a mental note. You don't have to write them down. It does waste time a bit, but you can write them down if you want to. Just have a mental check of which ones you can use. The question really does guide you, if I'm honest, though. Most of them, they really do kind of spell it out which ones you kind of have to use. It might not be clear where you use it, but you know you're going to have to use it somewhere. So angle at the origin, you're going to have to use the angle center theorem. Tangent given you and the radius, you're going to have to use the 90-degree perpendicular one. If they give you a semicircle, like if they give you a diameter, you're going to have to use a semicircle angle probably. If they give you a four-sided shape in a triangle, you're going to have to use a cyclic quadrilateral angle theorem and stuff like that. Okay, so that's the strategy there. But yeah, circle theorems do tend to come up. So again, it's good to as much as loads of people hate it, You know what I do too? Yeah, yeah, yeah. Don't try to lose marks, make sure you learn it for paper one. Okay, question 23. Only three more questions to go. These are like the grade 9 type questions, grade 8, the really hard algebra stuff, okay, at the end of the paper. So we want to write this in the form of this. So this is clearly rationalising the denominator. Again, you need to spot the topic in these sort of questions. So this is clearly rationalising the denominator. The denominator has a third in it. So we're subtracting two fractions together, but they're both irrational. So actually, before we subtract, we should make sure we rationalise both the fractions separately. I think that's the best thing to do. So 3 root 3 over 4 minus root 3. Well, you should know to rationalise a fraction like this, you're going to have to times by its conjugate. So to make sure you get difference of two squares, you set it to 4 plus root 3. Okay, you take the opposite of the third, the sign. So then let's times it across. So 3 root 3 times 4 plus root 3 all over 4 minus root 3, 4 plus root 3. Then you'd expand it. So 4 times 3 root 3, that's 12 root 3. Plus root 3 times 3 root 3, that's 3 times root 3 times root 3. This is just 3. So 3 times 3 is 9. Okay. And then the bottom, so 4 times 4 is 16. Use FOIL to expand it out. And then 4 plus root 3 is 4 root 3. Minus root 3 times 4 is minus 4 root 3. And minus root 3 times root 3, that's minus 3. And so then that simplifies to 12 root 3 plus 9. And then these cancel. The 4 root 3 might they cancel. And then you just got 16 minus 3 is 13. So that's rationalised. You know you've done it right because clearly the thirds have to cancel out. That's the whole idea. Okay, now we've got this fraction. You have what? 2 over root 3. That's very easy. You just times by root 3 to get rid of the third. Okay, so that's 2 root 3. And then root 3 times root 3 is 3. And that's it. And so then we can subtract them. So 12 root 3 plus 9 over 13 minus 2 root 3 over 3. And this is why it's best to rationalise both of them. Because now when we subtract, the denominators are easy to work with now. They're not thirds. So we're subtracting, you have to make sure the denominator is the same. So again, there's no obvious way to make them common. So we're going to have to just times across. So 3 times 13 is 39. So make sure they're both out of 39. Uh, okay, so 13 to 39, we have to times this top and bottom by 3. So 12 root 3 times 3, 36 root 3, plus 9 times 3 is 27. And then this one, 3 to 39, you're going to have to times by 13, the opposite. 13 times 2 root 3, 13 times 2 is 26. So 26 root 3. And then you simply subtract them together. I'm going to ensure I get more work in. I'm going to do it over there. Let's do it over here. So that equals then, out of 39. Well, 36 root 3 minus 26 root 3, that's 10 root 3. Cool. Yeah, just checking my answer. Okay, cool. 36 root 3 minus 26 is 10 root 3, and then plus 27 minus, oh, it's just plus 27, right? There's nothing more immediately we can do here. Let's check our answer. So it says we have to write it in the form a root 3 plus b over c. Well, it is in this form, isn't it? A is 10, b is 27, and c is 39. So that is our answer here. Cool. So again, like you should know by now how to rationalise a fraction, but you might not have done it like this, right? And whether you have to subtract two of them. But you should know how to subtract fractions and you should know how to rationalise fractions. If you can do that, you can do this question. Okay, just split it up, rationalise both of them separately, and then you can subtract them. Okay, that's the idea of this sort of question. Okay, rationalise them separately, and then go from there. Okay. Okay, question 24. Now, this one I really did want to include. They love asking this sort of question every single year. You know, it may not necessarily be paper one, although they do love. I've seen a lot of paper ones ask a question like this as well. But every single year they love asking these complicated ratio algebra questions, and it's the same process every single time because it's just essentially boils down to solving algebraic fractions. That's where this question comes from here. But you need to convert it into a fraction, and it's a ratio. Once you know how to do that, and it really does make sense once you see it, once you know how to solve them, it's quite easy, marks, in my opinion. But let's go over them. So with ratios like this, when you have two equivalent ratios, so you've got a one ratio is equal to another, whether the algebra or not, you can compare and equate them when they're identical. So when they have a common number. What do I mean by that? Well, if you put both of these ratios in the form 1 to n, for example, if you simplify it, so there's a number in both of them, so they both have a number 1, and then they're in a different number or terms of x. You can compare them directly. So I'm going to show you what I mean. So how do I get 1 on each of them? Well, you can just divide by one of the numbers, and that's the same every single time. Divide this ratio by x plus 9. Well, x plus 9 over x plus 9 is 1, which is where we get the 1 from. And then 5x minus 1 divided by x plus 9. Now this is same again to the same ratio, and we're going to do the exact same thing here. We are going to divide x plus 7, the first number, and divide x plus 7 here. Divide both sides. So it's kind of like simplifying a ratio, right? 2 to 4, divide by 2 to get 1 to 2. It's kind of what we're doing, but with algebra, okay? But that's a step. So we can divide by itself. So we get 1, and then over 2x minus 3 over x plus 7. That is the process every single time. You want to divide by one of the numbers or value or expressions or terms of x or stuff like that, anything like that. Divide by the first term to get 1 over 1 to something, okay? Same thing we hit with the other ratio. Divide by the first term to get 1 over something. Now, because both of these are 1 to something, 1 to n to 1 to m, different values of x, right? That means n has to be m. The right number, the right terms, the right hand side has to be the same, exactly equal to each other for this to happen. Because 1 to 1 means this has to be the same. So that means 5x minus 1 over x plus 9 has to equal 2x minus 3 over x plus 7. Now we've got an algebraic fraction we can solve. That is a step you want to do every single time to ensure you easily get the marks and do the right thing here. It looks very, very complicated, but if you do this approach to make sure you get 1 to something, you can easily then compare it and then you get to this. If you struggle with visualizing ratios, especially when they're throwing algebra like this, that's why they love doing it, to throw you off, to add algebra. Once, if you realize you can just do it like this, 1 to something, this is the approach I always recommend. 1 to something. Make sure you get So the numbers are the same on both sides, right? On the same ratio, different rate, the same on on the same ratio, the same side. One to something, one to something. That means you can compare them directly and equate them. Okay, you cannot equate them straight off the bat, but yeah, this is how you do it. Okay, I think this makes the most sense by far. I think this is the best way to approach it. Okay, hopefully that makes sense there. Again, you want me to go over that, explain it, let me know. But that's the approach. I think that's by far the best approach to this. That makes most sense. But yeah, so now we've got this fraction. Again, you just solve an algebraic fraction. If you know how to solve an algebraic fraction, hopefully you should do by now. This should be a dot. These questions you should be laughing at, really. Once you know this step, don't be thrown off. Once you know this, okay. Now we just solve it. So again, cross multiply. So 5x minus 1, x plus 7. So you cross multiply there and cross multiply there. That has to be x equal to x plus 9, 2x minus 3. Now you just expand and simplify. So use FOIL, expand, and not however you do it. You should get 5x squared plus 5 times 7, which is 35x, minus x minus 7, and that's going to be equal to x plus 9, 2x minus 3, so 2x squared minus 3x plus 18x, 9 times 2x, minus 27. Oh, plus 18x, not plus 18. There we go, lovely jubbly. So now we just simplify. So firstly, let's simplify both sides a bit more. So 5x squared plus 35x minus x. Um, that's going to be plus 34x minus 7, and that's going to be 2x equal to 2x squared minus 3x plus 18x. That's going to be plus 15x minus 27. Cool. Now we can move f to one side to get a quadratic, because obviously this is going to give a quadratic equation. So that means 5x squared minus 2x squared. Let's move it all to the left. That's 3x squared. Plus 34x minus 15. That's going to give you 19x. And then minus 7 plus 27. That's going to give plus 20 equals 0. Cool. Hopefully it should be right. We know we're going to be right because this is a non-calculated question, so we're going to get nice values. So we're going to have to factorize here, surely. Uh, don't use quadratic formula. You could use complete and square, but it's going to get messy. You're most likely going to have to factorize it. So now we're going to have to solve it. So solve by factorize. So how do we factorize? Again, you might have your own method. You should know how to factorize quadratics like this. But as a rundown, what you want to do is consider times with 3 with 20. So you want to find two numbers that times 60, so the 20, and add to 19. Okay, well, 60, 60 and 1, nope. 2 and 30, nope. 3 and 20, nope. Does 4 go into 60? Yes, it does. 4 and, well, 15, right? Yes. Well, 4, if you add 4 and 15, you get 19. So what this allows us to do is say, you split this up now. So 3x squared, 19x is 4x plus 15 plus 20. Okay. And if you've done it right, you should be able to factorize both parts. Okay. So let's do that. So in this first part, x is common. So x of, let's bring it clearer. So x of 3x plus 4 plus, and then 5 is common to both of them. 5 of, and then 3x plus 4 equals 0. And now we have a common factor in both of them, right? So we have, oh God, 3x plus 4, and then x plus 5 equals 0. And I'm going to write it up here then. From this clearly now, and that's plus 5. There we go. Set each bracket equal to 0. And you're going to get the solution. Uh, do, 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 I'm gonna okay. I'm gonna get rid of this bit now. Okay, that's just the factors of 60 to consider. Well, x is 3x plus 4 equals 0, so x is minus 4 over 3. Or x is, oh god, what have I done here? Or x is 5, and those are your solutions to the ratio, to the problem, right? Sorry, it's a bit unclear, but yeah, so that's what you get if you, minus 5, not plus 5. Cool, so those are your solutions. Hopefully you're happy with that. See, once you know how to solve algebraic fractions like this, you know, this shouldn't, it might be a bit grindy, a bit of work, but this should, this shouldn't be too unfazed. You shouldn't be too unfazed by this, right? I think the initial problem with this is just to formulate the fraction, right, which comes from making sure the fractions are identical, the ratios are identical. So 1 to something, which you obtain by dividing by the first number on each of them. And then you equate them. That's it, okay? Hopefully it makes sense. And now we're on the final question. Okay. Again, a lot of papers I've noticed, they love to ask multiple inequality questions like this. There's two different inequalities. They love asking this as a final question with a quadratic inequality as well. Okay, so we're told n is an integer such that 3n plus 2 is less than or equal to 14 and 6n over n squared plus 5 is greater than 1. Find n, or the values of n. So yeah, so really, again, it's just like I keep saying, split this up and do it one by one to solve the inequalities separately. So that's what we're going to do. So first, solve the first inequality. So 3n plus 2 is less than or equal to 14. So that's just a linear one. You should know how to do that fairly easily, hopefully. So then that means 3n is less than or equal to 12, subtract 12, and then n is less than or equal to 12 over 3, which is 4. Cool. And now we're going to solve the second one. 6n over n squared plus 5 is greater than 1. Now, this one is probably gonna obviously some people are like, oh dear, what happens? Well, how would you normally solve an algebraic fraction? Well, you times by the denominator, right? However, you can do that, but you need to be aware of a sign change. Now, you treat inequalities exactly like a fraction, like an equality, so equals 1. But the only difference is when you times or divide by a negative, you have to flip the sign. So what we need to do is essentially check that n squared plus 5 is positive or negative. But actually, look, n squared has to be positive, right? It has to be positive. Because it's a square number, right? It has to be at least 0. But then we add in 5. So if we add in a positive with another positive number, the denominator is positive. So actually, 6n is greater than n times 1 by n squared plus 5, n squared plus 5. We don't have to worry about flipping the sign because this has to be positive. So we can just times and then leave the sign as it is. We know for sure this has to be positive because of the fact that this is a square number and a positive is positive. So we can just simply treat it then like a normal equation, times across, and we get to this. And so then let's move to 6n to the other side. So we have 0 less than n squared minus 6n plus 5. And so yeah, then let's reverse the direction. So n squared minus 6n plus 5 is less than 0. So it's saying 0 has to be greater than this, so this means this has to be less than 0. Okay. And actually now, once we've got past all that, it's just a normal quadratic inequality. So how do we solve quadratic inequalities where we need the critical values and we need to sketch? So what are the critical values? Well, we're going to need to factor. Well, can we factorize? Well, yeah, because we know we need something that times to give 5 and add to give minus 6. And well, well, it's going to be minus 5 and minus 1, right? So it's going to be n minus. So it's going to be n minus 5, n minus 1, because minus 5 times minus 1 gets you 5, and add them to get minus 6. That means the critical values are n is 5, n is 1. Cool. And so what we do then is we sketch it. So, as with all quadratic inequalities, you must sketch it. Oh, I'll get rid of that. So the critical values are 1 and 5, which should be there. It intersects at plus 5, so it helps with aid sketching the graph. So the graph, and it's going to be a positive shape because the coefficient's positive. So it's going to look like this if you sketch it. Cool. Now we want the part where, so if say this is y is n squared plus this. We want the part where y is less than 0. So where the graph dips below the y-axis, okay? So it goes to the negative, which is going to be here, right? And it's going to be between these critical values. So it's going to be between 1, n, and 5. And it's going to be strictly between. So if it's equal to 1 or 5, the endpoints, it's going to be equal to 0, but it cannot be equal to 0. It has to be strictly less than 0. So it has to be strictly below these points here. So it's going to be strictly between 1 and 5. So this sketching helps us see the region we're interested in. So that is our solution here. So n is 4 and this. So these are the two solutions to these inequalities. But it says n has to satisfy both of them, and so it has to be both of them. So what we need to do is then lastly, you need to combine them two together. So you need to combine them together. So there are two ways of doing this. You can just stare at it and just reason a little bit and say, well, the n has to be at least 1. Cool. But it's saying here n has to be at most 4 and n has to be below 5. Well, if n is below 4, well, by default, n has to be less than 5. So this is the stricter inequality we have to take for the upper bound. Yeah. So this is true. The other way of saying this, if you're a bit unsure, is sketch the number line. Okay, well, plot both inequalities. So 1, 4, 5. Plot both inequalities, and again, you do need to know how to sketch, not sketch, draw inequalities on the number line. So draw them on the number line. Yeah. So draw the first one. N is less than or equal to 4. So that is going to look like this. And a 1 between n and 5, the second one, is going to be looking like this. So we want the region where n is on both lines. So that's going to be here, right? So we cut this off here. So it's going to be in this section here. So it's going to be the end point's going to be 1 here. And the end point here, the upper part, is going to be at 4. And it's going to be included, right? Because it's filled in. So so the part we're interested in where is both of them is n here. It's between 1, but not 1 because it's strictly above. And it's going to be at the top at 4, right? The cutoff at 4, and it's filled in, so it's going to include 4. Okay, so that's a way you can visualize it. So that is the final inequality that satisfies both of them. Okay, normally you'd be done there, but there's one hidden condition, at the end. Well, not hidden, but it says at the very start, which might have thrown some people off. It says n is an integer, and it says find all the possible values of n, which says we have to list them. This isn't a list of values, is it? But yes, so n is an integer. So we actually, what is it saying? So n has to be 1, 2, 3, 4, 5, 6. They're all integers and so on, or 0, -1, -2. So we're interested in integers. Okay. So what we need to do is consider every integer that fits into this. So obviously n has to be between 1 and 4. So let's consider n is 1, 2, 3, 4. Cool. Well, if n is 1, well, n has to be strictly above 1 because this is strictly 1 is strictly less than n. So n cannot be 1. Okay. But n can be 2 because 2 is between 1 and 4. So is 3. So then what about the endpoint 4? Well, n has to be less than or equal to 4. Well, 4 is equal to 4, so n can be 4 here. So that is also possible. And anything above 4, well, it falls out. So we can't have anything over than 4. We can't have anything less than 1. So actually, these three are our solutions. So our final solution is n is 2, 3, 4. And I draw a different bubble to indicate this is actually the final answer. And that is our solution here. And that's it. That's how you approach. Again, these two in particular, these uh, two final questions, it's the same. They love asking this, but it's the same process every time. It really is. They love asking two different inequalities for you to solve. Sometimes they ask you to solve two quadratic inequalities and then you combine them. If you combine them, do this method if you're unsure. Plot them both on the number line and see where they overlap. Okay. But other than that, you should know how to solve a linear inequality. You should know how to solve a quadratic inequality. So this question shouldn't be any bother. It should be an easy 5 marks. And this was the last question on the paper. I don't think that's bad going, in my opinion, once you know the process and break it down a little bit. Same with this ratio question. This was like the second to last question. I've seen this as the final question as well sometimes. Again, once you break it down, divide, you know, do this sort of thing, like divide through to make sure both have the same number, so you can equate them. Do the usual steps to solve for x. It's not bad going, is it? Really? But yeah, we've done it. We've finished. These are the so that's 88 marks. So it's a bit over 80. But all these questions, they do love to come up on non-calculated papers. So if you practice them all, you've gone over this stream. You know it would all be of benefit. You know, all these questions will benefit you in some way. But a lot, this is predicted. So these are the questions that I think are very, very likely to come up in paper one of a non-calculator. And I've seen the trend. I've seen them ask questions exactly like this type so many times on the non-calculator. And yeah, it's really important you do learn how to tackle all these questions, especially going for the high marks and the high grades. So yeah, and that's how you. And the idea of this is to show you how to tackle. Um, is to tackle. What's it called? It's to tackle all the questions that could come up, right? The most likely questions, the topics that come up. Okay, I'm looking at the chat now. That's why I was a bit of stop. So yeah, I'm going to look at the chat now. So I've done all the questions. Ask me if you want to look at a certain page or question. Let me know. But yeah, so exam board, Edexcel. However, especially GCSE, pretty much like 95, I'd say, percent of the topics are common in all of the exam boards. For GCSE, they have to be. It's very like off equal and stuff like that. A lot of them have to assess the same sort of stuff. And so if you're learning this sort of stuff, which is typical for non-calculator, um, uh, it will be applicable to all examples. Okay, so yeah, exams online. No, no. This isn't it. An online exam. This is just going over past paper. Yo, how are you? Can you do algebra shapes? Okay. I'll try and see if I can. What specifically do you mean by that? Shapes with algebra. So let's, look at Maths Genie. Okay. By the way, I do really recommend this website if you haven't seen it already. Breaks down every topic to grades and gives you questions and videos to explain stuff. Okay. Algebra shapes. A little bit vague, but I'll try and see what you mean. So do you mean like problems like perimeter and area, like but they give you like a variable instead of like um just having to find it a definite number? I'll show you what I mean. So area and perimeter, for example, uh, like this. So like a bit of algebra in there. So you got to find h. So there's like a variable there. Is that what you mean, or is there something else? Yeah. Oh, okay. Then let me just for this particular question. Then let me screenshot this. Put it in here. Yeah. Cool. Okay. Let me just copy the question then. It's a bit slow. Uh, okay. Let me copy it because I can't write it on here, so I have to write it on the other thing. Okay. There we are. Cool. So as an example then, so let's have a look at this question. So it says the diagram shows a trapezium with an area of 30 and a perpendicular height of h. Find the value of h. Okay, so it tells you the area. So area of a trapezium. Hopefully, you should know what the area of a trapezium is. So that's the first step for this. So area of trapezium. Well, that's going to be, I believe, half times the height times a plus b. I haven't looked at trapezium absolutely ages. Yes. So you add the two these two together, right? The two top, the bottom and the top length. So that's going to be 3 plus 7. So that's the area. That's just something you need to know the formula. So you half times the height, the top vertical height here, h, times by these two sides added together. Okay. So we're given the area is 30. So actually we can say 30 is now a half times the height. Oh God. Oh dear, what's going on here? A half times the height h times this bit here. So 3 plus 7 is 10. So then it says find h. Well, actually, but let's just simplify it then to get h. So 30 equals a half times h times 10. Well, 10 times a half, 10 divided by 2 is 5. So that's going to be 5 times h. Now, actually, hopefully, you should be able to solve this for h. So how do we get rid of the 5? Well, we times it by 5. To get rid of it, we're going to divide both sides by 5. So then 30 divided by 5 is 6. And that's going to just be h, because 5 divided by 5 is 1. So it's just h times 1, which is h. And that's your value there, h. So the idea of these sort of questions, like with most questions, if you have an unknown, work with what you know. So if we know the area is 30, well, we should know the area of a trapezium. And it's this formula here. And then you can go from there to work out h. So, yeah, so something like that then. Hopefully made some sort of sense there. Do-do-do. Oh, okay, good. Yeah, I'll stay around for a little bit though if there's any more questions. But yeah, the aim is I want to end the stream so I can publish it on YouTube and whatnot, so everyone can see it in full before the exam tomorrow. But yeah, anything else? Let me know. I'll say for like a minute or so. Yeah, let me know. But these are the questions, especially for higher tier. But some of these are for foundation and higher. The first 8 questions, they're useful for everyone. Um, uh, for non-calculator. So yeah, these are the questions that they love to ask and what comes up time and time again. But yeah, also I do apologise though the people chatted a bit earlier. The people commented half an hour ago. I didn't see it until just now. Do apologise. I had issues with my damn laptop, froze and everything. But yeah, I did. Hopefully, I've responded to everyone's comments now. But yeah, if you have any comments later on, this will be on my Twitch and on my YouTube linked, which is linked. So at any point, if you have any questions about anything, just let me know and I'll try to answer. Uh, but yeah, I'll stay on for like another minute or so, and then I think I'll leave it there and then publish it. Um, so everyone can see it in full. Yeah, but just to clarify, I think at Chill Gaming, I'm not a student, but I'm not done. I did like do maths higher up as well, degree and stuff. Uh, but I haven't done maths in ages. But I'm here now to do some GCSE work. So I'm not a student. I'm not a teacher either or a tutor or anything. But I'm just here to like give some sort of revision. I don't know, some sort of thing that helps people if they. But yeah, I'm just going over questions essentially. But I'm not a student. I'm like midway in between the student and the teacher, I guess. I've done this, God, when did I do GCSE? Like 8 years ago now. I did get a 9 in it, so I like to think I kind of know what I'm talking about. But I did go into A level and then degree level, so yeah, just to clarify on that, because I think some people think I'm a student. uh, okay, I think I'm going to leave that there then, unless someone has questions now. But hopefully that was help. I do wish everyone good luck for their exams and their maths exam tomorrow, for GCSE. Um, but yeah, I'm gonna leave it there. I'm gonna leave the stream and then export it, leave onto YouTube so multiple people can see it. And on YouTube, you can comment to me. So obviously YouTube has a public comment section. Twitch doesn't have that, unfortunately. But if you want to let me know anything there, just reach me out over there. Or, but yeah, I thought I'd come on and do this little stream to help people out. But yeah, I'm gonna leave that there. Then hopefully I've answered people's questions as well. Hopefully, you know how to do like the normal questions that come up now because these are the typical questions. But yeah, I'm going to leave that there then for now. Just to be aware as well to note there are two streams to this because my laptop did crash, so there are two parts to this. But yeah, I'm going to leave that there then. So good luck for everyone for the exam tomorrow or and thereafter. But I'm going to leave it there then. So thank you for your time.